Hey friends, welcome to Embed Idea. This is Tirthankar and you are watching 8051 tutorial series. In this video, I am going to discuss 8051 UART programming. So let's see what I'll cover in this lesson. First, I'll tell you the serial communication concepts. After that, the differences between serial and parallel communication. Then I'll tell you how serial communication is incorporated in 8051 chip. Then I'll show you UART registers and their details. Then I'll tell you about Baud rate and how to calculate the Baud rate through a sample application. I'll show you that. And at the last, I'll show you one experiment, and in that experiment, I'll control a LED through UART. So let's begin. Before knowing serial communication, you have to understand the serial communication in the context of parallel communication. So what is parallel communication? If I tell you by example, then parallel communication is sending a byte through 8 pins like this. Here, one byte is sent over 8 pins. That means each pin is carrying a bit. But serial communication is sending a byte through one pin. One pin is responsible for the entire byte. So each bit is sent serially. Normally, any microcontroller supports both. So what are the differences between serial communication and parallel communication? The major difference between a serial communication and a parallel communication method is where it is being used. Serial communication is effective for long distance communication, but parallel communication is not so good in long distance communication. And that is the major difference. Serial communication is relatively slower process, but parallel communication is a faster communication technique. Chances for data loss is very low in serial communication, but chances for data loss is very high in parallel communication, as all the pins are connected through wires. So let me give an example. Suppose you are controlling 8 LEDs which are situated 1 kilometer away from the controller and they are connected via wires. Then to send a 5 volt is very risky, because if a wire is teared up, then the data may be lost and there is no method to find out where the wire is teared up and how to rectify that. But in case of serial communication, it is there are many standards, many cabling standards and many wireless technologies which follows the serial communication method, and they have some error checking algorithms where if the receiver is not received any meaningful data, then it can send a negative acknowledgement, and then the sender will be responsible to resend the data. So these are the few error checking methods they follow. That's why serial communication is preferred over parallel communication when long distance communication is a concern. And serial communication is used by many wireless technologies like Bluetooth, Wi-Fi, etc. But parallel communication is used only in peripheral interfacing techniques, like if you have seen LCD 16x2, they are interfaced with any microcontroller through parallel communication technique. How serial communication is incorporated in 8051? See, there is a module inside any microcontroller. That module name is UART. That is responsible for serial communication. So UART stands for Universal Asynchronous Receiver and Transmitter. If UART is present in a microcontroller, then that microcontroller supports serial communication. And when UART is present, you can find out by seeing the pin diagram of that particular microcontroller. You will find two pins. One is RX, another is TX. So RX is used for receive a serial data and TX is used for transmit a serial data. So 8051 has a pair of this RX TX pin at pin number 10 and 11. See, these are the two pins which are responsible for serial communication. That means UART is present inside that microcontroller. So in 8051 we have main two registers. One is serial control, that is denoted as SCON. I have shown this SCON, and there is another register called SBUF. This is serial buffer. It is a buffer register of 8 bit. You if you want to transmit a data, you have to copy that data to SBUF. Now remember, to SBUF. And when you are receiving a data, then you have to copy from SBUF. Now I think you have understood that what is the work of SBUF. Now look at this SCON register. There are 8 bits, and let me start with the MSB, that is SM0 and SM1. These 2 bits set the serial communication mode. So there is a truth table. When SM0 is 0, SM1 is 0, then that mode is shift register mode, and the frequency is fixed, that is oscillator frequency divided by 12. It is a 8-bit communication mode. The second mode is 0. When SM0 is 0, SM1 is 1, that is variable 8-bit. Variable means we can change the speed of the communication, but in the first mode the speed is fixed, but in the second mode the speed is variable. In the third mode, which is shift register oscillator frequency divided by 64, here speed is fixed, but this mode is a 9-bit communication method. Now you can ask me this interesting question that SBUF is of 8-bit, then how can we transmit 9-bit? 9-bit communication is needed when there is one error checking bit, that is parity bit. You know about odd parity, even parity. When the data which is copied to SBUF is of odd parity, then one extra bit, that is 0, will be sent. And when the data will be of even parity, one extra bit of 1 will be sent. So when parity is included, 9-bit communication will happen, and SBUF can't contain all the 9 bits. It can contain only 8 bits. So where this 9th bit will be stored? It will be stored in SCONs. See, TB8, this will store the extra bit when the transmission process is going on. When the reception process will happen, then the extra bit will be stored in RB8. REN is used for receive enable. If you set this particular bit, then the 8051 will be able to receive. Now see, TB8 for 9-bit communication, it stores the parity bit. RB8 is used for 9-bit communication, it stores the parity bit. Now I think you have understood that how many modes, serial communication modes we have in 8051. There are 4 modes. The last mode, I have forgot to tell you that last mode is also a variable speed mode, but of 9-bit. So here we will be using the second mode, that is the variable speed but 8-bit communication. We will focus on that mode. TI, now let me tell you, TI is transmit interrupt. When 8-bit transmission will be finished, this hardware like 8051 chip will set this bit TI. You have to read that when TI is 1. When TI is 1, that means transmission process is finished. Similarly, when a reception process will be finished, then RI will automatically be set. You have to read that bit. Look at this value, as we need only this SM0, SM1, 01, that means the second mode. So if we select the second mode, then let me put the value 01. We don't need SM2. SM2 is used for multiprocessor communication. So let's put a 0 here. We need to receive. So receive enable will be 1. So 0101, and TB8, RB8 is not there because we are not using 9-bit communication. And TI, RI by default will be 0. So 0101, 0000. That means 50 in hex. That should be set when we'll do the programming. I have told you about speed. Now let me tell you the speed concepts. But before that, you have to understand why we call universal asynchronous. What is the meaning of asynchronous? Synchronous communication is when 2 devices are running on a same clock frequency. But asynchronous communication is when 2 devices have different clock frequencies. Like, let me give you one example. When a microcontroller is connected to PC, normally a microcontroller runs on several megahertz. but a PC's processor runs on several gigahertz. So there is a sheer difference between these two devices. Then the communication between them will be asynchronous. And what is the example of synchronous communication? It is the communication between your mobile phone's processor and memory card. That's a synchronous communication example. In asynchronous communication, two devices must negotiate on a speed of communication. Otherwise no meaningful communication will happen, because the speeds are different. So when they have negotiated on the same speed, that speed is known as baud rate. It is the selectable speed of communication. It is measured in bits per second. Technically, baud rate is symbols per second, but what we have in as symbols, we have 2 bits. So that's why it can also be represented in bits per second. In 8051, this baud rate is decided by timer 1, which is running on a auto reload mode. So let me show you. This is the formula given by the manufacturer. If you can recall what is auto reload mode is, then you have learned already that in auto reload mode, the higher order byte stores a particular value and the lower order byte actually acts as the timer. If you can't recall that, click on the I button where I have given the link of previous lesson. You can watch that video, then come back here. So this is the formula where we have to find out what value we need to store in the higher order byte. So here for timer 1, the higher order byte is TH1. So TH1 is equal to 255, means 255 is the maximum value it can store. So 255 minus oscillator frequency divided by 12. Now here I want to tell you that UART requires 32 machine cycles. So one machine cycle is of oscillator frequency divided by 12. That means 12 clock pulse. So this part FOSC by 12 is for one machine cycle, and for 32 machine cycle it will be crystal oscillator frequency divided by 32 into 12. That is the formula. Here I have written the actual one given in the data sheet. So 32 into baud rate. Remember this formula? I'll show you a sample calculation. The standard communication speed is used in many devices is 9600. This is the universal baud rate. It is supported by all the devices. So 9600 bits per second. If we want to achieve this baud rate, we have to set that baud rate. So here I have given two calculations, but I want to tell you, let's focus on this clock frequency 12 megahertz. So 12 megahertz, then baud rate 9600. So if we apply the formula, it will be 255 minus, let's convert 12 megahertz into hertz. So 12 into 10 to the power 6 divided by 12. 12 will be cancelled and divided by 32 into 9600. So here 12 will be cancelled and 10 to the power 6 is 1, then 60 divided by 307200. You can open the calculator and multiply these two, 32 into 9600. You will get 307200. So what we are getting is, we are getting a number in fraction 251.75. So it will be very difficult to store that particular number. We can only store 251, but there will be some errors. That's why there is a particular crystal oscillator available in market. This is 11.0592 megahertz. 255 minus 11.059200. It's converted in hertz, divided by 12, divided by 32 into 9600. What we are getting is a whole number. 255 minus 3 without fraction, 252. That means in hex it will be FD. So whenever we are using this 11.0592 megahertz, this particular number is divided, we can divide it by any of the available baud rate like 4800, 9600, 19200. That's why this clock frequencies crystals are available in the market. So we'll be using this frequency. Now let's go to the programming steps. So first, the black one steps are the general purpose. The red one is for transmission and the blue one is for reception. So you have to first set the SCON in 8-bit variable mode with setting receive enable bit. Then you have to set the timer 1 in auto reload mode, so you need to put a value in T mod. Then you have to load 0xFD in TH1 for 9600 baud rate. So then when you are transmitting, you have to copy the transmit data to SBUF and then wait for TI to be set. When this TI will be set, that means transmission is finished. Then you have to make TI 0. Similarly, wait for RI to be set. When RI is set, make it 0 and copy the SBUF contents in a variable. Then you can process the variable and take actions. We'll do this in form of an experiment. So let's control a LED through UART. So to save the time, I have already written the program. You can see it. I have already created a project from here, new project, and then selected MCS51 and created this workspace come project. So here I have already written, let me show you the code. One macro definition, that is for LED, which is connected at P1.1. Then I have declared a variable called constant character. It's an array of characters. So I gave it a name called C. Enter L, this is small l for on, and N for off. This is for LED. Then I have written 3 functions. Now let me show you step by step. So first is UART initialization. In short, UART init. SCON is 50 by selecting the serial mode to variable and 8-bit, and receive enable is set. So that tallies the hex value to 50. Then timer mode 0x20, that means timer 1 is set at auto reload mode. Then TH1 is FD. By this I am selecting the baud rate 9600. Then I have started the timer. That means the baud rate is selected and communication will happen. Now here at receive, this is the receive function, UART receive, while Ri equal to 0. While Ri equal to 0, it will wait for Ri to be set, and when Ri is set, make Ri as 0 and return the SBUF, the contents of SBUF, and after that we can process the data. Here there is another function called UART send. This is the transmission function. So I'll here send the entire character array. So here I have taken one variable called j, and then while Cj is not equal to null, SBUF equal to Cj, that means first j is 0. So C0 is this character E. Then gradually, while Ti equal to 0, it will wait for the transmission to be finished, and after it is finished, j will be incremented and Ti will be reset. Now if j is incremented, then j next time in this loop j will be 1, and then it will send n, then gradually T, E, R space L, and the entire character array will be sent. So these are the 3 functions. I have written it above main. So for that I don't need to declare the prototype. So here inside void main I have taken one variable, that val, and LED is 0, that means LED is configured as output. UART initialization, I have called this function, that means UART is initialized. Then I have called UART send, just to know the user that enter L for switch on the LED and N for off. It will send just that. Then inside while one, this variable equal to UART receive. Now this is a return function. So it will return the contents of SBUF, which will be stored in this val variable. Now I am checking if val is equal to small l, then LED 1, else if it is n, then LED is 0. That means if I get L, then LED will be on. If I get N, then LED will be off. So this is my program. I think you have understood this, and the entire program and the circuit simulation is available in the description box. You can download from there. So what I'll do is I'll build this code. So yes, it is built, 0 error, 0 warning. Now I'll open my Proteus design. So here what I did is I have connected one LED at P1.1. Now here I want to show you that there is a virtual terminal. You can go to this components list. So here there is virtual terminal. Drop it here. Connect RX to the microcontroller's TX, and microcontroller RX will be connected to this equipment's TX. So this is my virtual terminal. Now let me change the clock frequency to 11.0592 megahertz, and then I need to select the hex code. So I'll go to documents, then embed idea, then codes, then UART, then bin, then debug, then this is my hex file. So now everything is completed. Now I'll play. The simulation has started. Now see, the controller is transmitting it to terminal. Enter L for on, N for off. Now here right click and select echo typed characters so that you can see what I am pressing from my keyboard. Now here I am pressing L. This LED is on. Now you can see this LED is on. I am pressing N, LED is off. L, N, L, N. Now this is the primary experiment by which you can do anything, like any serial communication. Like if you want to connect Bluetooth with 8051, this thing can happen. You can build this. If you connect Wi-Fi, you can also build this, because this is the primary serial communication example. So both way communication is happening because controller has sent enter L for on and N for off, and from my keyboard I am sending L to switch on the LED and then N to switch it off. I think now UART communication is clear to you. So let me stop this, and in the next lesson I'll discuss the interrupts programming in 8051. If you like this video, then please share it with your friends, and don't forget to subscribe to Embed Idea because more lessons are coming up. Thanks for watching.